Okay. So the first thing I want to talk about is the different libraries that we're using and how they differ from each other and how we would use them and the things that we need to use out of each one. So main ones are stats models and scikit-learn. As I've mentioned a couple times, they both do linear regression with slightly different techniques, but the numbers and the results that you'll get from both of those, as long as you're using the same data, exactly the same. Let me just import all of these libraries to start. I'm going to be using the car miles per gallon data set again, just because. Setting my X, setting my Y as well. The whole thing is saved into data. I'm separating it into X and Y because scikit-learn needs it to be separated, but stats models actually prefer it together. And then here you can see that I'm fitting my stats models model. So with my stats models model, I get this result, an R squared of 707. Some insignificant variables we'll talk about. We won't really talk about what to do that for this session, but from a stats models output, what you get is mainly the significance of variables. Now, you cannot get this information out of scikit-learn. So that's unfortunate, which is why we kind of have to use both of them together in tandem. So I think a lot of you all have been doing this already, so that's good. I'll gloss through that. And then alternatively, yeah, on the other hand, we have our scikit-learn version. So scikit-learn, a couple steps. First, you just have to instantiate the model, and then you do your dot fit. Now, what scikit-learn has that stats models doesn't have is RMSE values, calculating your error values, because that's very important because it's another metric that you'll be looking at. So from here, and let me just run this real quick to show you all what this gives us. Here we have our train and test R squared and our train and test RMSE. These are values that you can't, well, you can get your train R squared from your stats models model, but to get these MSE values, now that's something that you can't get out of stats models. So what I've done here is first I fit my model, and then using the already fit model, I'm making the predictions for the train set and the test set separately, because I fit this on just the train set. And then from there, I'm calculating the average error between all of my predictions and the actual values. And I'm doing that separately for my train and my test. So what does this say? Here I have my R squared. You can see it's 712. The test is a little bit lower, which that's usually the case. My train RMSE of 4.197 just means that within my training data set, the average miles per gallon error is 4.197. Whether that's good or bad, you have to determine that based on context. I don't know the range of miles per gallon, but hopefully for your data set, you know the range of values and what is considered a okay or relatively okay RMSE. This test RMSE says that for my test set, I have like a 4.293 error. So within my test set, the average error is typically a little higher because your model has never seen the test set before. And the goal is to have these two numbers be close to each other so as to not overfit. Something that can happen pretty commonly is that your train RMSE is very, very low. And then because of overfitting to your train set, you get a very high RMSE. So that's why it's important to look at your train and test RMSEs. Any questions about this at this point? The tricky part is between your stats models model and your scikit-learn linear regression model, your data has to just be slightly different. Try and use the same train set for both. And I'll show you an example of putting it together. Try to use the same train set for both. You should have the same R squared for both. But yeah, you can see here we have to do the split of X and Y. I have an example showing you how I do both of them together. Coefficients. If you're just curious within linear regression, can you get, let's see, scikit-learn linear regression, what can you get out of the scikit-learn linear regression? You go to their documentation and you can actually see their attributes. So if you're curious, if you can get just the coefficient numbers out of your scikit-learn linear regression, you can get them out of coef and intercept. So if you ever wanted to like create a formula to do predictions, you can do that. And the way you do that is you get it out of the model. So you do linreg.coef for the array of coefficients, and this will match the order of your X train columns. And if you need your intercept, it's just intercept. Cool. Now, this we can only get after the fit step. So just to show you all, if I don't have this fit step and I just comment all of this out and I set a new linear regression, it has no, it doesn't have these attributes because it hasn't been fit yet. So you can only get these after you fit the model. There we go, and those are there. Okay, so those are just like the main reasons why we have to use these two libraries. I know it's a little finicky, but I'm gonna show you all something that you can do, which is write a function to use both of them more seamlessly. But any questions before I move on to that? All right, okay. Something that I want you all to start getting used to, I'm not going to really nitpick on this for this project, but something that's worthwhile getting used to is writing functions. Anytime you find yourself rewriting some code more than 2-3 times, it is worth writing a function. And so this is just an example of something that I wrote, that it's a function called model, and it takes in my train and test data and runs both models with stats models and scikit-learn and prints the information that I need. So if I run this function and I run my model on these train test split, which I had over here, I'm going to just use this train test split. This will spit out my scikit-learn results as well as my my stats models results. And as you can see, the R² value does match up for the train set. So what's happening in this function? First, for stats models, because I'm feeding it in the train and test separate, I just need to put my X and Y train back together so I can use it in this form. So this is being done here. I have my model there, and at the bottom, I'm returning the model summary so that I can have it in this nice format. If you ever tried to do print model summary, I believe it comes out not as nicely. There we go. It comes out like this. So if you're wondering why yours comes out like this instead of with the nice like pandas data frame format, it's because of the print statement. So you either do return or display. If you do display, it displays like this, Okay, so that's the stats models section. And then I'm just using the same data to fit my scikit-learn linear regression. And from there, all I did was just copy what I had up here and put it in a function, put it in the function here as well. So I have my train and test R² values and my train and test root mean squared error values. And this MSE is taking from the mean squared error method within scikit-learn and then taking the square root of it. Questions about this function? You can see that now that I have this function, every time I want to see all my results, I don't have to keep copying this over and over again. In this format, I just have to feed it different versions of X train, X test, Y train, Y test, and the model will run as well. As an example, you can see that, let's say I see these insignificant p-values in cylinders, acceleration, displacement, and let's say I want to drop these. So I just redefine my X as the X with these dropped, call it drop high P. When I do my train test split next, I, instead of X, give it drop high P. So my train test split is done. And when I rerun this, just by using this one line, I get all of my results all together. I have my train and test R², train and test RMSE values, and then you can also see the output here. So this is something that you can do if you just don't want to type the same thing over and over again for every model. I do recommend trying this out, even if it's not to do all of these processes at once. Maybe just a function that can give you maybe both your like train and test R² or RMSE, or maybe something that just does all of these modeling. You can potentially do something that gives you all of the normality checks, like the homoscedasticity check, the residual QQ plots as well. So yeah, I do recommend trying that out. That's something that you should get used to, but no pressure to do it for this project. I just wanted to talk about and outline what this would look like. Any questions about this at this point? Sweet, okay. So the next I want to talk about is scripting. And scripting is something that we're going to get more and more used to with time as well. And the idea of scripting is instead of using Jupyter notebooks, you can actually write functions in Python files. Now, it's very normal to first test your functions in your Jupyter notebook. So now I know that this function works perfectly fine, right? It worked on the initial data. It also worked on the data that I dropped some insignificant values, and it's still able to give me results. I'm not going to talk about evaluation too much at this point, but yeah, I know that this function works. So now that you know the function works, what you can do is actually take your function and put it into a Python file. This is going to be good to get used to, especially when you start defining more and more functions. By the time you reach your capstone project, you're going to be defining a lot of functions to help you out with your processes such that you don't have repetitive code. And yes, to some extent, you can keep your functions in your notebook if you like, but when your projects get longer and longer, that's just going to take up space, and it's going to make it just harder for you to present your work. So just to get used to it, if you find yourself defining some functions, I do recommend trying out putting them in Python files. And how that works is you just have to create a .py file. And I've done this over here. I created a functions.py file, and all I did was copy and pasted my function into there. You also have to import all the libraries. Of course, you can get even more specific with this, whereas you can see here, I don't actually need NumPy, so I could do that, but I pretty much just copy and pasted all the same things that I imported in my notebook, just to be safe. If you want to do this within your Jupyter, you can. You just go into new, and you actually do text file, and then name whatever you want it. Let's just say I'm just going to call it functions2.py. .py is the extension for any Python file, and then you can write your functions in there. So now that I have all my functions in here, and by the way, you can also do this in any code editor like VS Code. PyCharm is one that's getting more and more popular. I use one called Atom. So whatever you'd like. But if you just want like a quick way without downloading any additional software, you can do it here. Okay, so now I have this. I'm just gonna delete this super quick. All right, so I have my function defined in functions.py. So I'm gonna do to demonstrate this, I'm actually going to restart this and clear all my outputs. And I'm just gonna import it as a script. So I'm gonna re-import these libraries because I'm gonna need them. And then what I can do is I can import my model function. And so what I'm doing is from functions, because this file is called functions, I don't have to add the .py, it just knows to look for a file called functions. From functions, import model. Now model is the name of this method that I defined here. So import model, and you can do the alias if you want, you don't have to. I just don't want to type as many letters. And so I'm just importing model as M. So let's just say I do all of this initial work. Now remember, none of this is run yet. So I have all of this, I have my X chain, X test, Y chain, Y test, and I just feed it into M. And just like this, I can use my function, even though it's technically not defined within the notebook, I've imported it from a Python file. So my notebook is now a lot more streamlined. So I don't have to have the function defined in my notebook. I can just import it from there. And so notebook is shorter, outputs are a little cleaner. And that's like a really quick intro to scripting. As we get through the course, we'll be talking about more use cases of scripting. Pretty much like if you want to do any sort of like front end or like mini web page, you will have to do some scripting. But this is just like a gentle introduction to it. And I do recommend just getting used to, interacting with Python files as well. Nice. Any questions about this? Okay. If anything that you take away from this session right now, it would be that RMSE is something that you get out of your scikit-learn package that I do want to see. So maybe if you don't want to like make these functions and like deal with this at this moment, that's fine. Just know that you're gonna have to like refit models using scikit-learn just to get that RMSE number out. All right. Okay, if there's no other questions about this, I'm going to move on to talking about the presentation. So last call for questions about any of this stuff or anything related. Okay. So I have a presentation template and it comes from over here. And I also put a student example about this is basic for a different regression project, but you can kind of extrapolate the elements of that presentation. And here's a template. Now, this project is slightly different from our last project because we now have the new element of modeling. Whereas before we were just taking our data and drawing conclusions from the data itself. Now we're drawing conclusions from a model, technically. So how do you structure that presentation? So a lot of it is going to be the same. I would say you have your same title slide, and you also have your overview and your why, your motivation, your business case. Now, I would say when you're creating your presentation and as you're getting to like the point of making conclusions and drawing recommendations from your model, keep at the very top of your mind the business case. It's very, very important to keep in mind what your business case is, and that's really going to frame your presentation. So let's say, as an example, the business case here is you want to build a house and you want to figure out what features are that contribute most to an expensive house because you want to resell your house for more money, as an example. So then my motivation or my business case is I just want to figure out what I should focus my capital on as I'm trying to, I don't know, renovate a house. So same as last time, do a very high level overview of the data that you use, give an introduction to the data set and some very, very high level descriptors. I think this one's going to be pretty important. Where is the data from? If you decided to subset your data in any way, talk about that. I know that in this data set, it ranges from like around $70,000 to like multi-millions. So if you decided to like cut off any outliers anywhere, it's important to mention that here, because if you train a model on the full range of prices, you're gonna have very, very different results versus training your model on like part of it. And with that, maybe give some information about how many rows are in your data set. Also, like an example of what kind of features you're using in your data set. And you probably want to mention the features that you end up talking about later in your presentation. So that's an introduction to your data set. And then next you go into your EDA. I would say EDA for these presentations, you actually don't have to go very in depth. Typically the EDA that you use in this presentation will again tie to your business case and tie to your recommendations. So let's just say your recommendations eventually are like, okay, build a big basement. Maybe that's one of your recommendations. Your EDA naturally should have that. So it just ties in nicely. What I don't want to see, I don't want to see like a dump of histograms or scatter plots, because that, if you think about it, not useful for a non-technical presentation. In this case, like your audience would be someone who is using your business case. And so just think about, would they benefit from seeing, I don't know, like a scatter matrix or just a histogram of all of my features. So keep your business case in mind, but also your EDA naturally would connect with your business case and recommendations. So yeah, how you draw that is, let's just say you're looking at all your coefficients of your final model. You see that the square footage of your basement has the greatest impact on your housing price. Maybe a scatter plot of those two variables, basement and housing price, as well as if you want maybe a histogram of basements or something like that. So EDA, you don't have to go very in-depth into it. It just sometimes is helpful, especially when you're making conclusions that are related to some of your EDA. Okay, this is gonna be kind of the bulk of your presentation. And I say bulk, not in terms of like number of slides. And I wouldn't even say 1 to 3 slides. I would say like 1 to 2. Because here you're really just presenting your final model. It's not necessary to talk about every intermediate model and how your model improved. Let's just say you ran 5 different models before you got to your final model. I would say just talk about your final model and maybe include some baseline stats. So let's just say, make a small note that I ran my baseline model on everything. I had an R-squared of 0.3 and a RMSE of like $2 million. You can compare your final model results to that, because you need to have some benchmark. You need some point of reference as to how your model improves. So with your final model, I would say talk about if you did any specific kind of feature selection or feature engineering, mention that. So instead of showing an output for every single one of your models, maybe just talk about some of the main steps that you took. I mentioned last week that each iteration of your model, especially the ones that are in your notebook, should be a pretty significant decision that you made in your modeling process. And so maybe just list those things that you did. So maybe on this slide you have, okay, this is my final model. And what I did was drop high p-value or insignificant features, scaled XYZ variables, interacted these terms. And then I think that would be enough to just show your iterative modeling process. With that, you want to evaluate your model again, compare it to some benchmark, and interpret. And by interpret, I also, yes, the more important coefficients in terms of like their coefficient values and how it affects the price, but also interpret your R squared. That's something that I definitely want to see. Let me put that there. Interpret your R squared with the correct definition. And yeah. And then from your model, talk about your R squared. How well is the model fit? How well does your model predict? Show your RMSE. Oh, show RMSE. And then with that, you're showing off your model. Next, you have your summary, conclusions, and recommendations. This links back to your business case again. You are now using some of the coefficients and results from your model, tie it in with perhaps some of your EDA, and then make your conclusions and recommendations. So yeah, summarize all of your insights into a single slide, and if applicable, add any overall recommendations. If you need further EDA to show and prove why your recommendations are valid, you can do that as well. And then as per usual, you have a next step slide and your thank you slide. This is the same as before. I'll say the main new thing is for this presentation, a little bit less EDA and more about modeling. I think it is kind of difficult to decide how much of my modeling do I want to talk about for this kind of presentation. So I would put yourself in the shoes of someone who's using your business case, of someone who you would be presenting this to use your model, and then make decisions based on that. Like, do they care about the difference between my RMSE when I logged this variable versus not? Something like that. So ask yourself those questions. If you yourself are like, you do think that it is interesting to have in your presentation, then leave it in. I think a lot of these things can be quite subjective as well. All right, any questions about this? I know our presentations are coming up in 2 days, which I feel like that's super fast. So again, I want to say that you don't have to have your final model by then. You can also do your presentation on like whatever final model you have on Friday. So definitely take that, keep that in mind. You can definitely keep working on your project through the break week as well. But yeah, any questions or thoughts on that? All right, well, that went a lot faster than I had expected. Does anyone have any other questions regarding the project right now? If not, we can close out for the day. Okay, cool, awesome. If there's nothing else, y'all can Slack me if you need anything. I've been getting a lot of really good Slacks. Oh, one quick thing. A lot of people have been getting the warnings on Python. Every time you see, like when you run a cell and like a red box comes out, it's a warning. And if those are getting annoying, warnings basically mean that your code works, but something is like about to get deprecated or is not like the right way that you should go about doing a certain thing. And so what you can do is you can suppress the warnings, which typically is fine to do, especially when you're doing this kind of like internal project. But yeah, I want to show you all that you can suppress your warnings. So Python suppress warnings. So what you can do is you can import warnings and then use this code. They say I don't condone it, but yeah, you could suppress your warnings if you don't want to see those like red boxes pop up anymore, or if you have a lot of them popping up, you can do that. You can ignore. I think there's also an option to like only show the first one. But yeah, if anyone's curious about how you can not see those because your code will still technically work, you can suppress your warnings. Cool. let's see, one last thing. Don't forget to be committing to Git. Just a good way of saving your work. And I've seen too many projects like completely get lost because of not committing to Git. So please do that when you can. If anyone has any Git issues, let me know. But yeah. Any final questions or thoughts? Cool. Awesome. Well, if there's nothing else, I'll talk to you all tomorrow at this time as well. And yeah, have a good rest of your day, everybody. Slack me if you need anything. Bye.